Hello class, welcome to Unit 4, Lesson 4. Today we're going to look at solving exponential and logarithmic equations. We're going to spend a few days on this, so this is day 1, and your goal is that you can solve an exponential equation and round the value, and you can also solve a logarithmic equation. We're also going to be rounding the value for those two. So, steps to solving exponential equations. Isolate the exponential expression. Then what we're going to do is take the log or ln of each side. Then we expand the log, power rule, move power in front of the log, and then we solve for x. Okay, so this first one, our goal is to isolate the exponential expression. So we have 2 to the x. If there was a number in front of here, like 5, we'd have to divide both sides by 5, so we don't want to do that. Or we don't need to do that, I should say, for this problem. So since it's all by itself, we're going to go ahead and take the log on both sides. So log of 2 to the x equals log of 16. And then we expand the log, we use the power rule, we put the exponent in front. So we have x times log of 2 equals log of 16. Then we go ahead, and in order to get x by itself, it's x times log of 2. We divide both sides by log of 2. And these cancel. So x is equal to log of 16 divided by log of 2. If I type that in on my calculator, you just need to make sure we do log of 16, and then we end the parenthesis, divided by log of 2, and then end that one and hit enter. And our final answer is 4. X equals 4. So we're going to be doing some exponentials like that. So, example 1a. Okay. Solve for x, round answers to 4 decimal places. So always round to whatever the directions say. So here I have nothing in front, so I'm going to go ahead and do log on both sides. So I can now take the exponent, and since it's a binomial, we're going to put it in parentheses and write it in front. So I have x plus 2 log of 5 equals log of 28. I'm trying to solve for x. So right now it's multiplication. So I'm going to divide both sides by log of 5 to get that to the other side. So now I have x plus 2 equals log of 28 all over log of 5. Then our goal is to get x by itself, so it's x plus 2. In order to move that 2, I would subtract 2 from both sides. So x is equal to log of 28 divided by log of 5 minus 2. And we're going to type it into our calculator. It's always good to type it in, make sure that you can type it in. We have log of 28 parenthesis divided by log of 5, and the parenthesis, and then minus 2. Hit enter, and we're going to round to 4 decimals. So I go to my fifth, it's a 1, so it says to keep the 4 the same, so 0.0704. And I'm just going to write x is approximately, because we are rounding, so we write approximately, 2 little squiggly, so 0.0704. Okay, there is A. I go ahead and I look at B. I want to isolate the exponential, so it's really 6 times e to the 2x, so I got to get rid of my 6 first. So I'm going to divide both sides by 6. Okay. So I have e to the 2x. 40 over 6 does not simplify nicely, so I'm just going to leave it as 40 over 6 for right now. And then in order to get rid of e, whenever you have an e, you use ln. So if you have e to the x, we want to use ln on both sides. We actually really like e. Okay, I'll explain why here in a second. So we take ln on both sides. If I type in ln of e on my calculator, you will see that it's 1. This cancels. So we're going to put this in front, using our rule. So I would have 2x, and then ln of e is 1. So 1 times 2x is just 2x. ln of 40 over 6, and this is all inside the ln. And then our last step to get x by itself would be to divide by 2. Okay, so x equals ln of 40 over 6, all divided by 2. And so we're going to type it in and round to 4 decimals. So we would have ln, so left side 40 divided by 6. That's all on the inside of that ln. End your parenthesis, hit enter, and then divide by 2, hit enter. So 4 decimals. So we go to the 5th, which is this 5. So it would tell us to round this up to be 6. So 0.9486. That is my value for x, rounded to 4 decimal places. All right, there is B. Let's look at C. Okay, we're trying to solve for x. I see that's my exponent here, so I have to get this piece all by itself. So the first thing I'm going to do is divide by 4 to get rid of that. These cancel. I am left with 2 plus 3 to the 4x equals, 80 divided by 4 actually works out to be 20. So I'm going to write down, 20. So 20. Then I'm trying to get this by itself. It's 2 plus, it's a positive 2, so to move that to the other side, I'm going to minus 2. These cancel, so I have 3 to the 4x equals 20 minus 2 is 18. Then in order to get this out of the exponent, we log on both sides. That allows me to put the 4x in front. So I have 4x log of 3 equals log of 18. I currently have 4 times x times log of 3. So if I want to get x by itself, I can just divide by everything I want to get rid of. I want to get rid of the 4 and the log of 3. The 3's will cancel, not the 3, sorry, the logs cancel, and the 4's cancel. And so I have x is equal to all this, so I type it in. Biggest thing, please type this into your calculator and try it. The denominator has to be in parentheses. Okay, because otherwise what your calculator is going to do is take log of 18 divided by 4 and then multiply by 3. So on to our calculator. We have log of 18 divided by parentheses 4 log of 3. End this parenthesis and then end it so we have that this one is sealed off. Okay, hit enter. We are going to round to 4 decimal places, so I go to my 5th, which is a 3, so it says to stay the same, so it's 0.677. So that's our answer for C. So x is approximately 0.6577. Okay, so that's C. Now let's go ahead and move on to D. Okay, if I want to go ahead, I make sure there's nothing in front, so I don't have to, so I can just go ahead and log on both sides. Okay, so I'm going to take the log. Looks like I'm a little crowded, so I'd have x minus 4 log of 3 equals log of 5. And now I'm trying to solve for x, so it's x minus 4 times log of 3. So I'm going to divide both sides by log of 3. My log of 3's cancel, so I'm left with x minus 4 equals log of 5 over log of 3. Then I would go ahead and add 4 to both sides to get x by itself. So x is equal to log of 5 divided by log of 3 plus 4. So please type this one on your calculator. I want to make sure you can do it. I'm going to write the answer that you should get for this one. You should get 5.4650. Okay. And there is example D. If we move on to E, E is going to get a little bit trickier because I see I have 2 x's. So far we've only had 1 x. So our first step is going to be make sure there's nothing in front of the exponentials, which there isn't. And so I'm going to take log on both sides to get the variables out of there. So we have log of 5 to the x equals log of 4 to the x plus 1. Now I'm going to go ahead and put my variables down in front. So I have x log of 5 equals, this is x plus 1 as a group, so it's x plus 1 log of 4. And now what I need to do is distribute. This problem is very similar to when we were finding inverses last unit that looked like this. Okay, so that's what it looked like. So I'm going to distribute. So x log of 5 equals x log of 4 plus 1 times log of 4 is just log of 4. Now, I see there's two x's, so I want to get all my x's to one side. Subtract, it's a positive, so minus x log of 4 to this left-hand side equals log of 4. I'm going to give you a second. I'm trying to solve for x. What was our little trick that we did to get those by themselves? We factored, so I'm going to factor out an x. X log of 5 minus log of 4 equals log of 4. And now it's x times all this, so I divide both sides by log of 5 minus log of 4. So x is equal to log of 4, and if I wanted to actually use my rules, I could put these back together. Subtraction, so it could be log of 5 divided by 4. Okay, you don't have to do that. You can type it in your calculator just like this. Let's do it using this way. Biggest thing to remember is gotta put it all in parentheses. So I'm going to show you how to do this one. We would have log of 4 and this parenthesis divided by log of 5 and the parentheses. Ooh, I missed the parentheses. I told you guys you had to do it and then I forgot it. The whole bottom has to be in parentheses. Parenthesis log of 5 minus log of 4. Good. And then enter. So we go to our fifth, which is a 6. So it tells me I have to round the 5 up to a 6. So I should have 6.2126. So x is approximately 6.2126. Okay, and that is example E. F, we need to solve for x. You guys aren't fans of fractions, so let's go ahead and get rid of the fractions. We're going to multiply both sides by our fraction. Plus e to the negative x, e to the negative x. These will cancel, so I'm left with 50 is equal to 4, 1 plus e to the negative x. I will distribute my 4. And then my goal is to get my exponential by itself, which is e to the negative x. Okay, so first thing I need to do is minus 4. So I have 46 is equal to 4 e to the negative x. Then I would go ahead and divide both sides by 4. I'm going to check, does this give us a nice number? No, it's not going to give us a nice number. But if it's a decimal, that's like 0.5, that'd be okay. So we got 11.5. That's okay, let's write it as 11.5. If you wanted to keep it as a fraction, you can. E to the negative x. And then we have e, and like I said, we actually like e. It's all by itself. So now in order to get rid of e, we always ln on both sides. So ln brings my negative x in the front, and then ln of e, they will cancel. So we have ln 11.5 equals negative x ln of e. Ln of e is 1. So I have ln of 11.5 is equal to negative x. I don't want negative x, I want x, so I divide both sides by negative 1. So negative ln of 11.5 is equal to x. We're going to type this into our calculator to get what x is approximately equal to. And we would type negative ln of 11.5 and hit enter. 2, 4, okay, the fifth one is a 4, so then it stays the same. So negative 2.4423. All right, we have one last exponential to solve. Okay, it says solve for x. This one, I see two exponentials, okay, and it also has a constant. So it's not as nice as the one right here. There's no constants. If I tacked on a +2, it would have been a lot more difficult to solve that one. This one actually looks like a quadratic, like an ax squared plus a bx plus a c equals 0. So what I want to do is I want to be able to factor it, because that's how you handle quadratics. So here's the way we handle this. Okay, I am going to think of this. It's really e to the x to the second power. Because if I have power to the power, we multiply those two. So that's why it's e to the 2x. Okay, so I have e to the x to the second power minus 3e to the x plus 2 equals 0. And now what would be nice is if I could think about something that would make it a little bit easier. I am going to let u, a variable, it's called u, or going to u substitute, u equal e to the x. Okay, and I'm going to write, instead of e to the x, I'm going to write u. So now I have u squared minus 3, here's an e to the x, so now I'm going to write u, plus 2 equals 0. This is a problem we have handled before, so all I need to do is factor what multiplies to 2 but adds to negative 3. Minus 2 and minus 1. Negative 2 times negative 2 is positive 2. And then they add to negative 3, so it's perfect. So now that I have it factored, I don't actually want to solve for u. I want to solve for e to the x. So I'm going to plug that back in. So it's factored. So I really have e to the x minus 2 and e to the x minus 1. And they both equal 0. Now just like any quadratic, we use the zero product property. And we set each one equal to 0. So we have e to the x minus 2 equals 0. And e to the x minus 1 equals 0. So I go ahead and add 2. So I have e to the x is equal to 2. And how do I get rid of e? I ln on both sides. So x equals ln of 2. Good. Then move on to my other one. E to the x equals 1. And in order to get rid of that, I ln on both sides. So x equals ln of 1. Then we just need to go ahead and type them into our calculators. If I type in ln of 2, I get x is approximately 0.6931. And if I type in ln of 1, I get out 0. So those are my two answers for this quadratic. Okay, it's a quadratic exponential. Now we're going to move on. So we did exponential. Now we're going to do the opposite. What if we have a log equation? How do I handle a log equation? Okay, we're going to look at how to solve them when there's logs on only one side. So you may or may not have to do step 1. Okay, so but your first step is if there's multiple logs on one side to write it as a single log. Then we're going to write it in exponential form, and then we'll solve for x. Okay, so example that's here, solve for x. I have log base 2 of x equals 3. So I only see one log, which is nice. Now I'm just going to write it in exponential form. 2 to the third equals x. So x equals, well, 2 to the third, 2 times 2 times 2 is 8. Okay. Whenever we are solving logs, we need to keep in mind our domain. Okay, so we need to recall the domain for like log base b of x. Whatever is on the inside of my log has to be greater than 0. Okay, you cannot take a log of a 0 or negatives. Cannot. Zero or negatives. Negative numbers. Okay, so you just need to be careful with the domain. You can't have negative numbers in there. So after you get an answer, always be like, oh, is it positive? When I plug it back in. It has to be when you plug it back in. So if I take 8 and plug it in, that would be fine. Okay. All right. Example 2. Solve for x, round your answers to 4 decimals. Remember, if it doesn't list a log, it's really base 10. I'm happy there's only one log, so I'm going to do, write it in exponential form. So it's 10 to the second equals my answer, 3x plus 5. 10 squared is 100 equals 3x plus 5. And now, trying to solve for x, it's just a nice linear, minus 5 from both sides. I have 95 is equal to 3x. Divide by 3. So x is equal to, you could leave it as 95 over 3, but it does say around to 4 decimals. If you type it in, you are going to get 31.6 repeating. I will take 31.6 repeating or 31.6667. I'll take any of those. All right, B, I look at it, I see 1 log. Once again, pretty happy, so now I can just go ahead and put in my exponential. So I have 2 to the third is equal to x squared minus x minus 6. 2 to the third is 8. I look at this function. It has an x squared, so I know it is a quadratic. So I'm going to subtract 8 and get everybody to one side. So I have x squared minus x minus 14. We are hoping that I can factor this. What multiplies to negative 14 but adds to negative 1? Nothing. So we have to, sadly, we have to use the quadratic formula. But some of you love the quadratic formula, so we're going to go ahead and plug it into the quadratic formula. So x is equal to, remember, negative b plus or minus the square root, b squared minus 4 times a times c, all over 2a. So a is 1, b is negative 1, and c is negative 14, so we're plugging it in. Negative, negative 1, so positive 1, plus or minus the square root of 1, negative 1 squared. Minus 4 times 1 times negative 14, all over 2 times my a, which is 1. So, sorry, this is going to lead over here. So x is equal to 1 plus or minus the square root of, if I type in what's underneath my radical, I get the square root of 65 divided by 2. Now, it's important to type this in because some of you are making silly mistakes when you type it in. So it's 1 plus the square root of 65. You must hit enter and then divide by 2. Okay, so we get 4.5311. Then I'm going to do my other answer, which is 1. Oh, it's not just 1 though. No, it's 1. 1 minus the square root of 65, or square root 65, and hit enter. And then we're going to divide that by 2. So we get negative 3.5311. So I go ahead and write those down. So x is equal to negative 3.5311, and x is equal to 4.5311. Now, I have a negative answer, so I want to be a little cautious. If I plug that back into my log, okay, if I plug in a negative 3 here, would it still be okay? Well, negative to the negative 3.531 squared, negative 5.5311 squared, minus that number, minus 6. Will it be a positive? So let's check it out. We would have, can arrow up, grab it, make sure to put in parentheses, square it, and then we minus that number again, and then it was minus 6. Okay, so it's a positive number, so I can actually plug in the negative number. Okay, if you wanted to check your answer, you could also do log base 2 of it, see if it equals 3. So you could go ahead and do that and see if it works out. Log base 2. Log base 2 of our answer from up here. Oh. Log base 2. Arrow over. Go up. Hit enter. Hit enter again. Well, something happened. Did I type in the right problem? We want it to equal 3. let's see, just trying to look over my work. Maybe you caught it. So we have 8, then I have x squared minus x minus 6, subtract, I would have negative 14. My a is 1, my b is negative 1, and my c is 14. So I should have 1 plus or minus, let's make sure that's 65. Should be. Negative 1 squared minus 4 times negative 14. There it is. My radical should not be 65. This should be the square root of 57. Okay, so I'm going to quickly tell you what the right answers are. Hopefully you caught that I made a mistake when I typed this in. So it should be the radical of 57. So 1 plus the square root of 57. And then you divide by 2. So one answer should be 4, positive 4. 4.2749. And then your other answer with 1 minus, and we divide that by 2, should be negative 3.2749. So those should be our two answers. We were like pretty close. We had 10 and we should have had 8. But when you plug those in, they both will be positive on the inside here. Okay, so we can actually take the log. So those are both valid answers. Sorry about that. I don't know why I had 65. So, all right. So moving on to C. Okay. We see C and we have 1 log, which is great, and it's really base E. So we're going to do, put it into exponential. It's e to the 4th equals 7 minus x. I am trying to get x by itself, so I'm going to minus 7. E to the 4th minus 7 equals negative x. And always please don't type in your answer until you're all the way done. Then we divide everybody by negative 1. So we have negative e to the 4 plus 7 equals x. Now we're going to type it in and we're going to get our answer. So negative e to the 4th plus 7. Okay, so we get negative 47.5982. So I write that down. Then I would say if I plug it in, if I do 7 minus a negative, if you minus a negative, you're really adding, so it's going to be a positive number. So I can write it down, but just be careful. All right, D gets a little trickier. I have 2 logs, so step 1 is to rewrite them. If I have addition, I can rewrite them with multiplication. So we're going to have log base 4 of x plus 1 being multiplied equals 2. So then I have log base 4 of x times x is x squared plus x equals 2. I have a single log. Now I'm going to put into exponential. So I have 4 squared equals x squared plus x. Then I have 16 equals x squared plus x. I see it's an x squared, so it's a quadratic, so I got to get it equal to 0, minus 16. And then I would go ahead and I would try and factor this to find my solutions. Once again, multiplies to negative 16 but adds to 1. There is nothing, so I would have to use quadratic formula. I'm going to let you, oh my gosh, quadratic formula. So go from there. I would recommend trying to do it. If you do, as long as I didn't make a silly mistake when I did mine, you'll get 3.5311 and negative 4.5311. And since this is an x, just by itself, can't plug in the negative, so you'd only have this answer. All right, E. I look at E. I see more than 1 log, so I'm going to rewrite it. It has subtraction, so we rewrite it with division. So I have x minus 2 over x plus 1 equals 2. Then we go ahead, change a base. We're going to write it as exponential, so 3 squared equals x minus 2 over x minus 1. So I have 9. And then we don't like fractions, so I'm going to try and get rid of it. So I'm going to multiply both sides by my fraction, or my denominator. These cancel. distribute, I have 9x minus 9 equals x minus 2. I look at the equation I have, they're all x to the first power, so it's linear. So I can just go ahead, try and get all my x's to one side. So I would have 8x, and then add 9 equals 7. And then if I go ahead and divide by 8, x is equal to 7 over 8, or x is approximately 0.875. All right. So there is that one. I hope you caught it. Where's my silly mistake? I wrote x plus 1 here, but I did not keep writing x plus 1. So x plus 1, there we go. So this would be plus 9. So I would need to subtract 9 from both sides, which gives me negative 11. So I was going to erase that. So x is equal to negative 11 over 8, which is negative 1.375. So I have a negative, and I would say if I plug it into here, negative 1 something minus 2, it's still negative, so actually this doesn't work. And if there is nothing that works, then it is a no solution. So something to be aware of. All right, so questions, please make sure you write them down. Otherwise, your homework is listed at the end here. 2 through 42 evens, 48 and 50. Please come see me if you have questions. Otherwise, I will talk to you later. Have a good day.